A very good morning to my lecturer. My name is Woo Swee Hin, and today I'm going to give a presentation for the video assignment. And the video assignment is about question 1C, D, and 2A. Okay, first, 1C. For 1C, we have to analyze the gas pressure of the air in the tank with the height given, which is H1, H2, H3, and also the density of water, oil, and mercury. And using the Pascal law, we can apply that the P1 plus the pressure of water, pressure of oil minus the pressure of mercury, since the mercury is applying the pressure backward. So we can just apply the formula equals to P2. And since at the point 2 we know that the pressure applied is the atmospheric pressure. So we just have to sum out the value, throw inside, and we can find P1. And here's the value of the P1, but here's not all. The P1 is the absolute pressure, and so basically we have to find the question, which is the find and answer the question, which is the gauge pressure, by having P1 minus the atmospheric pressure, the absolute pressure minus atmospheric pressure, to find the gauge pressure. And here's the answer. And for D1, we also apply the Pascal law to find and calculate the force in Newton that required to hold the weight, and also to answer the second question, to lift the car to a certain elevation. First, without any elevation, just simply apply the Pascal law formula. P1 equals to P2, which is F1 over A1, F2 equals to F2 over A2. Just sum up, and here's the force that required to lift up the 13,000 Newton weight car, which is just 26 Newton weight, quite surprisingly low. And the question given is require us to find any elevation, and just simply apply the formula, Pascal formula. But here's something different. We have to sum or include the pressure applied by the oil inside the container, which is this hydraulic oil, and which with specific gravity given, because we don't know the density of the oil, and we can find it throughout or by using the specific gravity, which is the density of oil divided by density of water. And throughout calculation reverse a little bit, we can find the density of water and throw inside the formula, which is F1 equals to A1, F1 over A1 equals to F2 over A2 plus the density pressure applied by the oil. And without any value of the H, we can assume the H equals to 1 to prove that there's a elevation, and we can get that F1 is higher than the F1 for the question 2 is higher than the question 1. Why? If the car is lifted to a certain elevation, the F1 will increase due to elevation difference that generates higher pressure, which also means the higher force. And here's the evidence, which 26.683 different with 26 higher. And for question 2, more specific 2A, the question required us to determine the tension in the rope for both conditions, without immersed in the water and immersed in the water. Without immersed in the water, we can just apply the formula of the balance equation. The balance equation, and throughout the diagram, we know that the tension force is equal to the weight of the block without any buoyant force. Why? Because we are not immersed in the water. And in the question, the mass of block is not given. We can find the mass of a block by multiplying the density of block with the volume of the block to find the mass of the block. And the weight is calculated by multiplying the gravitational acceleration. And here's the answer. And since the block is not immersed in the water, the tension in the rope are equals to the weight of the block. And here's the tension force. By with the condition of immersed in the water, we have to plus the buoyant force, which is equals to the density of is water times the volume of the block and the gravitational acceleration. And here's the buoyant force. And the tension in the rope of the crane when the concrete block is suspended in the sea or maybe in the water, we can find out that the tension tension in the rope is equals to weight minus the buoyant force, because the buoyant force applied in a opposite direction. Then we can get the calculation, the answer, which is the tension for the in the rope when the block is immersed in the water. Okay, I think that's end of the presentation, and thank you, sir, for the teaching and anything else. You did your best, and we will do our best in the final. Thank you, sir.